Humans have a natural ambition to discover, to explore the unknown, and push the boundaries of what we believe is possible. From the earliest days of our existence, we have sought to find new land, to chart the uncharted, dive deep into the ocean to chart unseen floors, and uncover species that have eluded us for centuries. This desire to uncover the mysteries of our world is embedded in our DNA, and this desire has driven some of the most transformational, pivotal moments of human history. But what happens when there's nothing left to discover on Earth? But what happens when every ocean trench has already been explored, every mountain peak climbed, and every rainforest mapped? What's next for humanity when the final frontiers of our planet have already been discovered? The answer, as you already probably know, is past our atmosphere out into the vast outer space. The next chapter in humanity's journey is the exploration and colonization of the outer space, starting with our nearest neighbors like the Moon and Mars. While we've already made significant strides like landing on the Moon and sending a rover to Mars, the next step is going to take a significantly larger level of equipment and technology, because the real challenge lies not in simply going and visiting these places, but building a sustainable life there. This shift from exploration to habitation brings with it an entirely new set of challenges, opportunities, and existential questions. Before we can imagine thriving on Mars and the Moon, we have to address some seriously daunting challenges. The first and biggest question is, where exactly should we locate these habitations? On the Moon, some scientists are suggesting that on the lunar poles are the best places where we could put habitations there, because there's ice potentially in the craters. As you know, water is very essential for human life in general, but it also can allow us to do things like generate rocket fuel and create oxygen from it. On Mars, the story is very similar, where they're locating these areas where there appears to be water underneath the surface that they want to choose and habitate. But locating these habitats is simply just the beginning. And once we've chosen where to build, we must address the monumental task of designing technology that will allow us to thrive in places that are very hostile. Unlike Earth, the Moon has no atmosphere, so it's constantly bombarded by radiation and micrometeorites. Mars, on the other hand, does seem to have a thin atmosphere, but it does still get a lot of radiation from outer space. And another major problem they're predicting that we could have if we habitate Mars is that the massive dust storms on Mars could cause big issues for solar technology or equipment, and a host of other problems that it comes with really dirty dust clouds that'll block out the sun. Creating livable spaces involves engineering habitats that can withstand the harsh environments while also providing the essentials of life like water, oxygen, and food. We need innovations in material science, in energy storage, and life support systems. For example, researchers are exploring the use of in situ resources, which essentially is using the stuff on Mars and on the Moon to build structures and energy stores while you're there. Lunar regolith, which is the stuff on top of the Moon, they believe could be used to create structures, while they believe that the carbon dioxide-rich atmosphere of Mars could really be used for creating fuel and oxygen. Beyond the obvious physical challenges, there's also major questions like how will this place be governed and how will the society there be structured? Like, who owns Mars or the Moon? International treaties like the Outer Space Treaty of 1967 state that no country can claim sovereignty over a celestial body. But what about private companies and people? As space exploration becomes increasingly commercialized, the line between exploration and exploitation becomes increasingly hazy. Government bodies will have to address issues like law and order, resource distribution, and equity, which, as we know, usually ends in war. Not to mention, without careful planning, space colonization could really end up in a have or have not type situation where the ultra wealthy live up on Mars and the rest of Earth's dwellings live in some sort of uninhabitable version of Earth. Additionally, how will societies function in such an isolated and dangerous environment? The physiological strain of living in such a tight environment, with limited resources and contact with loved ones. Ensuring the mental health and well-being of space settlers will probably require advancements in things like psychology and medicine. At the very heart of sustaining life in outer space is the need for self-sustaining things that create water, food, and energy. To be practical, to become a long-term habitation, it has to be self-sustaining. We can't send stuff from Earth forever and have people live off that forever. So for it to be practical, people that will live here will have to be innovative and figure out ways to live off the places that they're at, using the local resources that are available in places like the Moon and Mars. Food production in space does pose some unique challenges. On Earth, the food we get out of the ground is created from the natural ebbs and flows of the Earth, the winter to the summer, and the way those seasons work and how it creates food in abundance. A lot of those things don't exist on these places that we want to habitate. Hydroponic and aeroponic systems, which grow without soil, offer a potential solution. These solutions could offer settlers to grow plants in a stable environment, providing fresh produce even in a place like space. Scientists are also exploring ways that they can build plants that can survive in zero-gravity places and use less water. The other very critical resource, water. Both the Moon and Mars do have water on them, but to extract it and use it, we'll have to use some technologies. Stuff like basic filtration systems and advanced recycling. Basically so that we can drink the water now at the way that we have it on Earth, and that we can use it over and over and over again. Energy is probably the final piece of the puzzle, but also maybe the most important. Solar power is a promising option for both the moon and Mars, but it does also offer some problems. The moon experiences 2-week-long nights, which means that we would need seriously advanced energy storage units that could hold that energy for at least a fortnight. Mars, on the other hand, which does experience a day similar to what Earth does, which is 24.6 hours every single day, does just receive less sun because its distance is further away from the sun. These issues do also make it necessary for us to explore other options like nuclear power. Something like nuclear power could provide a reliable and consistent energy source. The push to colonize Mars and the moon is more than just survival. It's about exploring the boundaries of humans' potential. In the process of solving these complex issues, we will inevitably solve some problems that would really help life on Earth as well. Things that we already need on Earth, like renewable energy technologies, water recycling systems, and advanced medical techniques could really benefit us on Earth as well as the people out in outer space. Space exploration has always been a driver for innovation, and this doesn't seem to be anything different than the usual. Moreover, the pursuit of colonization poses important questions to us as a species. What does it mean to be human when Earth is just a blue dot in the sky? How will our cultures, values, and traditions change as we expand into a multiplanetary species? That reminds us that space exploration is not just an engineering or innovative thing, it is a philosophical question. Ultimately, the colonization of Mars and Moon is not just up to a nation, a corporation, or an individual. It is a collective endeavor that will require the collaboration of everybody on the globe. By pooling our resources, technology, and creativity, we can overcome a lot of these challenges that are posed with leaving Earth, which is something that has never happened before. People coming together on a global scale. So the journey to the moon and Mars is not just about where we're going, but who we're becoming as a people. It is a testament to our curiosity, resilience, and ambition. A reminder that even as we reach for the stars, we remain one humanity. The question is not if humans will become multiplanetary, it's when. When is it going to happen? We don't know. But let me know what you think in the comments down below.